Hello, I am Christian Dave ARTs of PSCYP21, and today I will discuss a lesson about priority scheduling algorithm with example. Priority scheduling algorithm is a method of scheduling process based on priority. In this method, the scheduler chooses the task to work as per the priority, which is different from other types of scheduling. So priority scheduling involves priority assignment to every process, and processes with higher priorities are carried out first, whereas tasks with equal priorities are carried out on the first come first serve (FCFS) or round robin basis. An example of a general priority scheduling algorithm is the shortest job first, or SJF algorithm. So what is priority scheduling? So from the name itself, priority scheduling means you have to select the highest priority first. So a priority number is always represented as integer, and an integer is associated with each process. So it means that you have to assign a priority to each process if you are going to use priority scheduling algorithm. So the CPU is allocated to the process with highest priority. So it takes the smallest integer as a highest priority. So if there is 0, it is the higher. And if there is 1, it is the highest, like that. So here in priority scheduling, it may have the preemptive. It means that it follows the preemptive scheduling. Whenever the priority process comes, the CPU has to stop the current execution of process and executes the priority request process. So it also schedules in non-preemptive. The priority scheduling also works on non-preemptive scheduling. So the shortest job first is priority scheduling, but in reverse order means it takes the smallest one first. Priority in the inverse of predicate next to the CPU burst time. So here in priority scheduling, you will came for some problem. So what is that problem that you came across in priority scheduling? So the main problem that you can came across in priority scheduling algorithm is starvation. So what do you mean by a starvation? Starvation is when a low priority process may never execute. Means whenever there's suppose a P1, there's suppose certainly the P2 came the highest priority, it will be executed, and the P1 has to be in wait state. Next, the P3 has came, which is the highest priority than P1. Next, we came for the P4, and all the priority interrupts are coming in priority processor. So the P1 has to wait until all the processes that are executed by the CPU. So there is a change that the P1 may never execute. Also in some cases, the P1 never executed, and that you call it as starvation. Like you are waiting eagerly, we are waiting hungrily, like the P1 has to wait until the CPU is given a permission to execute or given a chance to enter into the CPU, that you call it as a starvation. So every problem has a solution. So you can have a solution for this problem, and that solution is what you call an aging. So aging means as time progresses, if you take the time progresses, increases the priority of the process. Means here that you are assigning some time to each process in the according to the priorities. So there is a chance to execute the low priority. Also means whenever the time is over, the processor has to execute the process even though you are getting the highest priority request. So that is the aging. So that's the solution for the starvation. Now let us see the example for this priority. So here's my example. So let's take the process time. Let's take P1, P2, P3, P4, and P5. And the burst time for that process, let us take 10, 1, 2, 1, and 5. And you have to take the priorities. Also, like I said earlier, whenever you are introducing the process, you have to assign the priorities. Then the CPU will take the highest priority process. So the priorities will be 3, 1, 4, 5, and 2. Now, let us see how the processor executing in the CPU. So the first, which is having the highest priority, I said the priority will start from the small integer. So here, you can see that the 1 is the smallest. So therefore the P2 will be the highest priority. So that's why it's written at the first box, it's P2. And the burst time is 1. So the 1 will be written here. Next, we have the P5, which have the burst time of 5. So how come it became 6? So you're going to plus this. 1 plus 5 is equals to 6. So we're gonna write the 6. Then next is P1, which have the burst time of 10. Gonna write P1. Then 10 plus 6 is 16. So you're gonna write it there. So fourth is P3, which have the burst time of 2. So 16 plus 2 is equals to 18. Lastly, the P4, which have the burst time of 1. 18 plus 1 is 19. So this is how the CPU is going to be calculated. Means take the process. So, and what is the average waiting time of this? So the P1 is 6. And I write 6. And the P2 is 0. Then I write plus 0. And the P3 is 16 plus 16. Plus 16. So the P4 would be 18 plus 18. And lastly, which is the P5 would be 1 plus 1. So we're gonna put an close and open parentheses. There you go. And so after we put the close and open parentheses, it will be divided to 5. So you'll get 8.2. And that is the average time of this. So the drawback of this is priority scheduling is only the starvation of the low priority process. So that is all about the priority scheduling algorithm. Thank you for listening.